again to our lesson. Today we are going to study on other methods of separating mixtures, and we shall go direct to solvent extraction. Now, solvent extraction is a method which is used to extract a solute from its original solvent by using a second solvent in which it has a higher solubility. Now, separation through this method. Filtration uses a filter paper with very tiny pores through which liquid particles pass easily, but the solid particles cannot pass. The liquid that passes through the filter paper is called a filtrate, while the solid that remains on the filter paper is called a residue. The procedure of obtaining oil from seeds. Now, the groundnuts are first crushed using a mortar and pestle. Then, propanol is added so as to dissolve the oil. The extract is then filtered and evaporated using solar energy so that all the propanol may evaporate. Propanol is more volatile, so it evaporates, leaving the oil behind. The seeds are crushed in order to increase the surface area for the reaction. Now, what are some of the applications of solvent extraction? Now, one of them is that it's used in the extraction of natural dye from plants. It's also used in the extraction of oil from nuts and seeds. Then also in the extraction of some herbal medicine from plants. Other uses include extraction of caffeine from tea and coffee, and also in dry cleaning to remove dirt and stains. So these are some of the uses of this solvent extraction. Now let us now move on to chromatography. Now, chromatography is a method which is used to separate mixtures of colored substances which have different solubilities on a moving solvent. Example is a mixture of dyes. For you to be able to separate a mixture of dyes, then you use the method of chromatography. Now, this is made possible due to the differences in the stickiness of the dye and also differences in solubility in the solvent. Now, the study of colors is normally called chromatology, and chromatogram is a visible record showing the results of chromatography. In other words, after performing chromatography, then we are able to show the results on a chromatogram. Now we shall see the procedure on which we can be able to obtain a chromatogram. Yes, as we move on. Now, what makes it possible to separate substances through this method is 1. The differences in stickiness or viscosity of the substance. Number 2, the differences in solubility of a moving solvent. And number 3, differences in the densities of the dyes. Now, there are some points which need to be noted whenever we are carrying out chromatography, and one of them is that most soluble dyes move to the farthest distance. So as long as the dye is soluble in the solvent, then it will move to the farthest end of the filter paper, and the least soluble dye moves the least distance. Another point is that most sticky dye moves the least, while the less sticky moves the farthest. Something else to note is that identical substances will move equal distance from the baseline, and insoluble dye does not make any spot on the chromatogram paper. Also, the number of spots indicate the number of substances in that mixture. So for example, if the mixture makes 3 spots, then it means that there are 3 substances in that mixture, and so on. Now, pure substances will make only 1 spot on the chromatogram, and most dense moves the least distance. Those things which are dense, those colors which are dense, they will just move a short distance and form their spot. Now, we need to learn about some basic concepts in chromatography. For example, what is the solvent front? Now, this is the farthest distance reached by the eluting solvent on the chromatogram. So in our case, if we were using propanol, then the farthest distance the propanol reaches on the chromatogram is our solvent front. Then we also have the baseline, which is the point at which the dye to be separated is placed. Now, something else is solubility, and solubility is the tendency of a substance to dissolve in a solvent, while adsorption is the tendency of a substance to stick on the adsorbent material. For example, we have the particles of a substance sticking on the filter paper, if that's what we are using as our adsorbent material. Therefore, that tendency to stick onto the material is what we call adsorption. Let's look at the procedure of separating colored pigments in green leaves. So the first thing you are supposed to do is crush some green leaves in a mortar using a pestle. These green leaves can be leaves of spinach, kales, they can be leaves of flowers, and so on and so forth. So first of all, you crush them using a mortar and pestle. Then next, add the solvent propanol as you continue crushing. In some cases, we use ethanol in cases where propanol is not available, or even acetone. Then, after mixing it with the solvent, decant the extract into a clean beaker. Then, using a dropper, place 1 drop of the extract in the middle of the filter paper. Leave the drop to dry and place another on the same spot. Now repeat this procedure for the 3rd time. Using a clean dropper, add the solvent dropwise on the same spot, each time allowing the solvent to spread. Allow it to dry and make a diagram of the filter paper showing your results. Now look at our chromatogram. You can see the spot at which we placed our dye. Then it is followed by the yellow ring, then the green ring, and finally the solvent front. Now we need to understand why the green ring appears next to the spot and the yellow ring is further away. Now, so the 2 rings are observed. The yellow ring, which is due to xanthophyll, and the green ring, which is due to chlorophyll. The xanthophyll is more soluble than the chlorophyll, and it is also less sticky, so it moves to the farthest distance than the chlorophyll. The different rings can be cut off and put in a suitable solvent so as to obtain the color of the extract. Now, another chromatogram would look like the one below, where A, B, and C are pure substances, while D is a mixture of A and B. Now, in this chromatogram, you find that there is the baseline, which they are calling the origin. And in the baseline, we place the pure substances A, B, C, then the mixture D. Now, after performing chromatography, A will show a single spot because it's a pure substance. B will also show a single spot because it's pure. C will also show a single spot. Now, look at the spots and the distances they have moved from the origin. And that can be able to tell you which of the three pure substances is soluble, is very or slightly soluble in that solvent, and at the same time which one is less soluble and more sticky. So we say the one which is more soluble and less sticky moves the farthest distance, and in our case it is pure substance A. And the one which is more sticky and less soluble is B, because it moves a very short distance from the baseline, which is the origin. Then when you look at D, D is a mixture of two pure substances, and in order to be able to identify them, you look at the level of the spot. Which other pure substance has their spot at that level? And in our case, we are able to realize that B and A have their spots at the same level as the two spots of D, which is a mixture of both. Now we have all those methods of separation summarized in a table below. For example, we have the physical properties of the components. One component sublimes. Now, if you have a mixture whereby one component sublimes, then an example would be a mixture of sand and iodine. The method of separation in that case will be sublimation. Then, when one component is magnetic, and an example of such a mixture is sulfur and iron filings. So the method of separation in that case is use of a magnet. Then another physical property could be one component is soluble and the other is insoluble in water. An example is a mixture of sand and salt. So the method of separation in this case is you first dissolve them in water, you filter so that the sand remains as a residue, while the solution of salt passes as a filtrate. Then you evaporate the filtrate in order to be able to obtain salt. Now another example is the solid is soluble in the solvent. An example is a mixture of salt and water. In that case, you have to first evaporate. You can also perform crystallization. You can also do simple distillation, depending on how the question is set. For example, if you want to obtain both samples, both water and the salt, then you use simple distillation. If you only need the salt alone, you evaporate the water, and so on and so forth. Now, another mixture would be a mixture of two solids which are both soluble in the solvent. An example is sodium chloride and sodium chlorate 5 and water. Now, in such a case, you perform fractional crystallization, whereby each of the substances will crystallize at their own temperature and they will be able to be separated. Then a mixture whereby the solid is insoluble in the solvent, for example sand and water, you just perform filtration. Then if it is two immiscible liquids like paraffin and water, then you use a separating funnel to separate the two. And if the two liquids are miscible, like in the case of water and ethanol, then you perform fractional distillation and you shall be able to collect ethanol at 78 degrees Celsius and water at 100 degrees Celsius. If both substances are gases and have different boiling points, for example, oxygen and nitrogen, then you perform fractional distillation of liquefied air. We shall discuss that in our next subtopics. Then we have a case whereby the substances have different densities and solubilities on moving solvent and differences in stickiness. And an example is a mixture of colored dyes. In that case, you use paper chromatography to be able to separate them. Now, some applications of chromatography include: it is used to identify the use of burnt substances, for example, steroids in urine samples. Now, this normally happens with sports people, whereby some of them may decide to use some steroids in order to add into their stamina. And in such a case, and to avoid such, normally the urine samples are taken before they perform the particular sport, and then chromatography is performed on them so as to be able to identify any of them who has used these steroids. Now, it is also used in the food industry to identify contaminants in food and drinks. Now, this can happen, for example, in cases whereby there is a suspected food poisoning. Maybe people have taken some food or drinks and they get sick. So the leftovers could be taken for chromatography in order to be able to identify exactly what caused the food poisoning. Okay, in the cosmetic industry, it is used to identify harmful substances. So in most of the creams ladies apply on their faces, then sometimes we have some harmful substances which are contained in them. And in order for them to be identified, then chromatography is performed on such creams. Some of these substances can be harmful to the skin. They may cause skin cancer and other skin conditions which are harmful to the client. Now, it is also used as an analyzation technique in both pharmacy and medicine to test the purity of drugs. So this one happens in the medical field, whereby some drugs are tested for some impurities or some impurities, let's say. For example, sometimes we have some medication which is in circulation, and after a short while, you hear or a message is sent that the drugs are recalled back into the pharmacies. Now, the reason for this is because maybe during analyzation, they realize that there is an illegal component or a component which is not good to the health of the patients. Therefore, such is done through chromatography. Now, that marks the end of our discussion. Let us look at some sample questions on chromatography and solvent extraction. And maybe you can give your answers in the comments. Then, we can discuss them. Now, the questions are: what makes it possible to separate substances through fractional crystallization? What is solvent extraction? Part B, why is propanol used as a solvent and not water during extraction of oil from nuts? Part C, why is the solution left in the sun? Then we have a third question. The table below shows liquids that are mixable and those that are immiscible. Look at the table, then use the information given to answer the questions that follow. Name the method that can be used to separate L1 and L2 from a mixture of the two. Then describe how a mixture of L2 and L4 can be separated. Then the last question. Study the table below and answer the questions that follow. Now look at the table and answer this question. Describe how the mixture of R, S, and V can be separated. Thank you so much for being part of this lesson. I hope it's going to help you in your revision. And also, in case of any comments, please write it on the comment section, or any answers or clarifications, and I will be able to get back to you. Thank you. Bye till the next